Hello, welcome to Maths with Mr Amison. In this video we're going to be practicing how to use tangent circle theorems. If you need to recap this topic then please watch Mr Chowdhury's video. I'm going to start by showing you these two examples, then talking through them. Once I'm finished, then copy it down and have a go at the question on the right. Feel free to pause anytime. Okay, so for the first example, the first thing I recognised was that this angle here was 90 degrees because the angle between a radius and a tangent is 90 degrees. If that's 90, we have 180 degrees in this triangle, so therefore those angles add up to 180, which means that this has to be 38 degrees. And because we have a tangent here and here, it means that the line from that point where the tangents meet to the centre, that bisects this angle, which means it splits this angle in two equal pieces. So x therefore is going to be the same as y. So if this is 38, then y is also going to be 38. For the second question, the first thing I noticed was that this here was 13.3. That's because if we have a tangent here and a tangent here, okay, then that length is the same as that length because the distance from where a tangent meets the circumference to a point is the same as the distance from where another tangent meets the circumference to the same point. Basically, where two tangents meet here, the distance from there to where those tangents touch the circumference is the same, so that has to be 13.3. The next thing to notice was that y here is the same as y here. That's because a radius bisects a chord, and it bisects that chord at 90 degrees. So that length there would be the same as this length here because the chord has been split into two equal sized pieces, and the angle here would have to be 90 degrees. Because of that, we can use Pythagoras theorem to figure out the value of y, like so. Alright, so copy that down, make sure you understand. If you need to recap Pythagoras theorem, then feel free to do that. You might also need to use trigonometry for these circle theorems because you can see there's quite a few angles that are 90 degrees with these theorems. So often trigonometry and Pythagoras comes up in these kinds of questions. But if you're ready to carry on because you're comfortable with Pythagoras and trigonometry, then feel free. Now you've had a chance to have a go, let's go through it. So in this question, the angle there is 90 degrees because that's where a radius and a tangent meet. Then we have 45 degrees down there because these two angles are the same because that line bisects the angle. So if that's 90, that's 45. Then we can use the fact that tan 45, because this is a right angle triangle, we can use trigonometry. Tan 45 is opposite over adjacent, so tan 45 is x over 52. We can multiply by 52 to get 52 tan 45 is equal to x. As you can calculate x to be 52 because tan 45 is one of our exact values of trigonometry, which is 1. So x is 52. For the next part, we have y here, and that is also 52 because this line here is the same length as this line here. For the next question, we have these two angles are both 90 degrees. That's because the radius and the tangent are at right angles to each other. So they're both 90, which means this quadrilateral here is going to be really important. Now, we're trying to find that angle, but we don't know what this angle is. We can figure it out. We can figure out that that angle is 86 degrees because that is the angle at the centre, and this is the angle at the circumference, using a circle theorem that we covered previously. So if we've got all of that, that means all the angles in this quadrilateral should add up to 360. And when you solve this equation that you get, you end up with x being 94 degrees. Okay. Here are 6 questions for you to try then. They do get more difficult as you go through. Each question uses a variety of different techniques and different circle theorems. It could be any of the tangent circle theorems, but each one of these questions has at least one tangent circle theorem in them. Alright, have a go, see how you do. So here are the answers. For the first question, we get x is equal to 107 degrees because of the angles between a radius and a tangent being 90 degrees, and then these add up to 360. Here, similarly, we have this angle being 90, so we can use Pythagoras theorem. 12 squared plus 5 squared is equal to 5 plus x squared. Well, we could figure out this length first. 5 squared plus 12 squared is 169. So this whole length here will be 13. So if we take 5 away from 13, we should get our value of x. For this question again uses Pythagoras theorem, but we have to recognize because that's a radius, then that's also 4 centimeters, and this length here is 4 centimeters as well. Because of that, we know we have 5 centimeters across here, 4 centimeters here. This is a right angle, so this we can use Pythagoras theorem to get that x is equal to 3. Question 4 is a bit trickier. We have the angle between the radius and the tangent being 90 degrees, but we also have this radius bisecting this chord, which means the angle here is also 90 degrees, which means we actually have similar triangles because this angle is common between them. They both have a 90 degree angle in them, which means the final angle must be the same, so this angle must also be x. So if that angle's x, this angle's also x because this is an isosceles triangle. Then we have because we have a right angle here, we can use trigonometry. We have the adjacent and the hypotenuse, so we're going to use cos. So cos of x is 2 over 4. So cos of x is a half. Now, cos of x being a half, that's an exact value. Cos of 60 is a half, so x must equal 60. Question 5 is quite tricky. We have to use the fact that we have 90 degrees down here, so this is 80 degrees. This is an isosceles triangle, which means this base angle is also 80 degrees. Then we have 20 degrees here because we have 180 degrees in a triangle. And then this angle is half the angle at the center, which means angle x is 10 degrees. For question 6, we have y degrees here, which we need to calculate first. And we can do that because we have this length is 7, so we know that this length is also 7. And this angle will be 90 degrees. It's the angle between a radius and a tangent. So when we calculate the angle y, we can do tan of y is 7 over 10. And the reason why we'd calculate the angle y is so we can calculate the length of this line here, which is x. So we have to do that angle first. And once we have, we get 34.992 and it carries on. If we use the exact value in here rather than just 992, I've just missed out the dot 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 just to make it fit. And then we have sine of this angle. Well, because we're going to use this right angle triangle now, where the right angle is here, sine of y is equal to x over 10. Sine is opposite, sine of the angle is opposite over hypotenuse. And when we solve this, multiply both sides by 10, then put it into a calculator, we get x being 5.73 centimetres to 3 significant figures. That one really is quite complicated. Question 4 was rather complicated as well. Those ones I would say are particularly challenging, so if you struggled with them, don't worry about it. But I hope you found it useful to go through some of these and see how tangent circle theorems can be applied. And remember to use Pythagoras and trigonometry. If you're good at those two things, then it will help you with your circle theorems tangents work. Thanks again, and bye for now.